Alright, we're back on this 2000 Miata that got the new engine doing the air conditioning. And what do we see here a little different? So I got the idle raised to about 1600 RPMs. That's one thing that is different from the first video. So I'm more of an ideal RPM for the compressor. Idle is not an ideal RPM. What else do you see here? Now that the engine is warmed up and the radiator is warmed up, we now have a nice steady airflow of hot air being provided to the evaporator, because the hot air is blowing in this direction and it's getting sucked right down where you see my wire right here. That's where I have my temperature sensor. I wanted to know what the temperature of the air going down inside the ducting work, the cowl, to feed the evaporator. I have it on fresh air mode. So I got 110 to 113 degree air feeding the evaporator. My air outlet temperature is 51 degrees. And look at the suction side and the liquid line. Now this is at over 1500 RPMs, sitting still. But there's still no load really over the condenser. The condenser is getting cold air, and outside is about 62 degrees. It's really cold outside. So on a hot day with hot air going over the condenser, this would even be hotter. And then put on top of that, throw the vehicle outside in the sun and have a heat load. So you'd have heat gain striking that black dash, creating heat, striking the interior, making the interior hot. You'd have the sun hitting the top, making the top hot, and all that would put more heat load on top of the evaporator. So what you would see is a much higher level of the pressure would go high, your suction line temperature would go up, your liquid line temperature would go up. So your supply temperature, everything would go up if this was in real world. Now, one thing I was really lucky, had one real good friend owns a body shop, and he would let me, he retired a few years ago, but he would let me do air conditioning in his heated booth. And I would have him crank it, and I would perform the same test on a vehicle, and I would dial up the heat in the booth up to like 100 degrees. So, and he had his heat lamps, because he would be heated booth, he had heat lamps in there, and I would move the heat lamps over to the sides and over the windshields, and I can literally watch my temperatures on all my refrigerant circuits go up and down as I turn things on off. So I could literally put a couple thousand watts of heat load by putting a heat lamp that was an infrared heat lamp, turn it on, and literally watch the interior go up, because as that infrared light would go through the windshield and strike the dash would heat up and add heat load inside the car. So that was not the hot air that was coming down that was 105 or 110 degrees. That's radiant heat coming off the heat lamp. So there's a difference between convection and radiant heat. So this is our steady state right now. So now let's throw it on recycle. And now you'll see what our fresh air, let's throw it on recycle. So now we're at just over 1500 RPMs. So let's go over to recycle. So now I'm going to recycle this air inside here. That's like 50 some degrees. So now we're going to see the compressor start to short cycle, as you would say in HVAC terms. So now we're in recycle. Now look at our suction line temperature. It's going down. Now we're about to shut off. When we get towards 32 degrees, our compressor will cycle off. On this per day, and look at that, our superheat and subcooling changing. Boom, there, just turned off. So that's the compressor turning off. And we'll watch it there, just turned on. Because there's no load, this 117 degrees is no longer feeding the evaporator. It's the cool air inside feeding the evaporator. And the high RPM, because we're at 1500 RPM. So let's take our temperature that we were pulling in when we were in the fresh air mode. We'll take that there, that's the thermistor. And we'll move this out here in front of the vehicle. Right there. So that's the air temperature going in there. Oh, we got that much roll around on. There must be no plastic guard under here. Yeah, there's no plastic plate underneath the car. Check our temperature out. Oh no, I'm looking at the wrong one. Brain dead. So it's only about 60, 62 degrees outside, and we still got 70, and that's from the hot air rolling around here and the hot air pushing in around underneath the car, coming up to this point, heating up this thermistor, because it's not 70 degrees out. Now let's take it into idle, and you can hear the compressor cycling in and out. Okay, now we're at idle. We're going to be below 1,000. Are we going to go below 1,000? No, it's going to hold it right around 1,000. So it's cool inside the car. And it's cycling the compressor out slower now because the compressor is no longer operating at its efficient speed. It's much slower. It's no longer getting 100-degree air feeding on the evaporator. It's just recycling the internal 50-some degree air. And that's why we're pulling right down into approaching 32 degrees on our suction line. That's our evaporator temperature. And you can see our supply is gone down because we're recycling air. We're not taking in fresh air. We now can get colder because we're recycling the interior car air. And because the compressor speed is slower, it no longer can make the higher head pressure. So our head pressure is staying down because of the compressor's RPM, because the engine RPM is down. Unlike a car with an electric compressor, it just keeps it up there no matter what. It doesn't care what the engine RPM. I've had HVAC guys comment on my YouTube saying just step on the throttle to get that electric compressor, having no idea that when you're in a hybrid engine and you step on the throttle, it doesn't make the electric compressor go up on RPMs, lowering your suction side. All right, that's it for now, guys. We're call it a day. I got to record some data and get out of here. See ya.